page 50. You need a book? Okay. Okay. So, you ready? You can sit here if you want. We'll share. All right, so we have a function. Oh, yes, this was a favorite one. What did we decide yesterday? First of all, one of the important things that it's saying is both f and f prime are increasing. All right? So if you were to do, they want the derivative at 3. Suppose we do the derivative at 3. Is Zach here again? He was here yesterday. 48.05 minus 39.2. This is where we started. Someone get a calculator. All over 3.1. This is the calculator portion. Minus 2.8. What do we get? I think it's 29.5. 29.5. All right. So if we look at your answers, remember this has to be strictly increasing. We have 20. If the slope at 3 is 20, am I increasing? If you need to, you can do more slopes. But if this is 29.5 between 3.1 and 2.8, and I have the slope at 3, I started to decrease if I'm at 20, correct? 27.5 would represent a decrease. 29 would represent a what? 29 would be a decrease because I'm at 29.5. 30 is a possibility, and then we've got 30.5. So the question is it 30 or is it 30.5? So this is what I would do. I would now do the slope between 3.1 and 3. So if we did 48.05 minus 45 over 3.1 minus 3, what are we going to get? What is that going to be? Pardon? It's 30. So what we're saying is from 3 to 3.1, our average slope is 30. From 2.8 to 3.1, we have 29. Was that 30 or 30.5? 30.5, that's what I thought. All right. So if this slope right here is 30.5, this is 29.5, what do you think the slope should be at 3? 30, because if it's at 30.5, we're not increasing, we're staying the same. Next. Because that means it's on a concave up portion for f to be increasing. So that means it can't be linear. Yes? Is this on the page before it? All right. Ooh, look at that derivative. So I'm thinking it says the first derivative is given by how many points of inflection does the graph of f have? So when you have a first derivative, how are you going to get points of inflection? You're going to have to look at increasing, decreasing. So get your calculators out. All right. So what are we going to, now, is your calculator in radian? Yeah. Make sure it's in radian. It's got to be in radian for calc for this test. Whole test. You go to mode.
We get the calculator on the whole test.
No. The first 28 questions are non-calculator. And then 4 free response out of 6 are non-calculator. Find a seat. All right, so here we go. You ready? So we're going to go to y equals, and we're going to type in x, maybe, x minus 4. Did I get a minus? Okay, 4, and we need e to the negative sign 2x. Aren't you glad this is calculator? E to the negative sign 2x. All right, everybody there? Now, listen, before I do anything, I'm going to go to my window, and I'm going to change my window to match what they put there. Look what they put there. What did they tell us? 0, and then I'm going to do 2, and then I'm going to hit pi. Why do we want to do this? This is a really slick hint. You will not look at anything that you're not supposed to look at. You know what I mean? If you have too big of a window, you might get more than you think. All right, so they want points of inflection, correct? What are we going to look at? Increasing to decreasing. Increase to decreases 1, decrease to increases 2, increase to decreases 3, decrease to increases 4. So it is 4. What do people, if someone chooses 3, what are they looking at? They're looking at the x-intercepts, which is wrong. All right, next question. Rachel. FCAT for today? Okay. Julia? 87, is this on the same test? Yeah. Rachel, are you not going to come back and get it?
I can pass it to her.
Rachel's 14. Noah, you are 1.
Oh, she wants to know if she did not want to.
I don't know which is better. Some of the batteries are going dead. All right. The answer was 4 on 83. 81. Julia, what am I doing? 87. All right. 87 says the figure above shows the graph of f prime. So the first thing you want to make sure you're aware of is this is a first derivative graph. All right, on the open interval -7 to 7, if f prime has 4 zeros, 1, 2, 3, 4, can you count them? You see them? All right. How many relative maxima? All right, so do you see? Now, I'm going to draw a number line, but you're going to have to look at your review booklets, all right? So you're looking at your review booklets. This is page MC 53. And what are some of the, we've got -7, and we've got 7. And it does something, it comes up, then it does this, then it comes up, and then it goes down, and then it comes up. Oh, that's not very good. All right. So it has 1, 2, 3, 4 zeros. Now, the fact that the graph is below from here to here means the original is what? Decreasing. Because this graph is above, what does it mean is happening here? Increasing. Because this is above, what does it mean? Increasing. Because this is below, what does it mean? Decreasing. Because this is above, what does it mean? Okay, they want maximums. Oh, maybe I should have put my little arrow here. How many maximums? 1. Oh, I got those probably in 1980 or 1990 from some architect.
I downloaded a software that filled my computer with all sorts of malware. Rick had to come and clean it out. It was supposedly a reputable software that you could build your own one.
I think I gave them to Mandy,
Did you?
so you'd have to do copies of them.
Okay.
You want to have fun?
I just thought I'd come by and show you this.
That is crazy.
Okay. Go. A particle moves along a straight line. The graph of the particle's position x of t at time t is shown above. What is our graph? It is an original graph. All right. We're on MC12. The graph has horizontal tangents at 1 and 5. I understand that. Point of inflection at x equal 2. For what values is the velocity increasing? So if I want to know, let's think about this. I've got original. What do I know about the velocity? It is the first derivative. We'll do x prime of t. But now if I want to know when is this increasing, what's necessary? the second derivative. Now, how do I look at original for second derivative? Concavity. All right? So it says, for what values of t is the velocity of the particle increasing? Remember, they told us the point of inflection was at 2. So are you going to be increasing when you're concave up or concave down? So I would say it is 0 to 2. A. And what was the answer? 21 was A. Okay. Aditi. 18 on the page before. Oh, that's a good one too. This one I do remember from yesterday. So let's see what we have. We have XY plane we have. This is number 18 on MC11. So we have this equation, x plus y equals 12. And k is a constant, and it's tangent to the graph, so I've got this curve. This line is the tangent line to the curve. By the way, this curve happens to be y equals x squared plus 3x plus 1. Obviously, it shouldn't be concave down, but whatever. What can you tell me about the y value on the line and the y value on the curve? They're the same. In fact, this ordered pair is on both, correct? What can you tell me about the slope of the tangent line and the derivative at that point? Oh, that's where we're going to start. What is, if I solve for this and get k minus x, what is the slope of the tangent line? What kind of one? Negative 1. And what is the derivative of y? 2x plus 3. Can you solve for x? Subtract 3 and divide by 2. So what we have is we have an ordered pair negative 2 something. Now, do you agree this negative 2 something is on both of the curve and the line? How can I find my y? Which one? Why can't I plug it into the line? It's a lot easier to plug in. You have what on your line? 2 unknowns. So we're going to say y equals negative 2 squared. Negative 2 times 3 is going to be a negative 6 plus 1. So that's going to be 5 minus 6 or negative 1. So now if I know this x and the y that's on the tangent line and on the curve, am I going to now be able to find k if I know both x and y? So we've got negative 2 plus negative 1. What is k? Negative 3. Next. Okay. So because this line is tangent to my curve, this point, this ordered pair, is on both the line and the curve. And the derivative of the slope of my tangent line is the derivative at that point. Because what is a derivative? Slope of a tangent line generating function. So if I find the slope, I subtracted x, my slope is negative 1. The slope of this tangent line has to equal this derivative, which is 2x plus 3. With me, Rachel? So I subtracted 3, and I found my x, which gave me half of this ordered pair. What it didn't give me was my y. If I were to take my x plus y equals k, and I were to substitute negative 2 right now, am I going to be able to solve for either y or k? No. That's why we had to go to that equation up there. Morgan had her hand up. Okay, we're on 5490. So this is MC page 54, number 90.
The last one was negative 3.
It was negative 3. Oh, I'm on MC 54. I'm getting there. Okay. Oh, this is a great one. So it says functions f and g. All right, so I have a bit of an issue with this one, though. This is my issue. It says f of g of x equals x. To truly be an inverse, this also has to be true. It's not enough for f of g to equal x. G of f of x must also be x. So I find this a relatively poorly written question, but then who am I to speak with the test I wrote for C-Block, the last test I did. All right. So anyway, this is supposed to tell us that we're working with inverse functions. And I think they even said, okay, so they didn't tell you. It was kind of a sneaky way of telling you it's an inverse. So what we're going to do is we're going to get that table that Mrs. Sprinkler, what a name, isn't it? Phyllis Sprinkler. She was my AP Institute teacher.
She's the one that taught you the.
Taught me this table. I had her actually for BC and AB. But I had her for AB after I knew calculus. All right, so F, G happens to be what? F inverse. So if F has an ordered pair of 3, 8, what's the ordered pair for G or F inverse? 8, 3. If the derivative of F is 9, what's the derivative of F inverse? 1/9. So if they want G prime of 8, yes, G, which is F inverse of 8, what is it? They want G prime, which G is F inverse of 8. There's the 8. What is the derivative? 1/9. Yes. F is 3, 8 because they said F of 3 is 8. And since they gave us F, then G is the inverse. And they gave us a derivative, yes. How do I know? Say it again. Because G prime is F inverse. Okay? So if I want G prime of 8, we would not say G prime of 3 because it's a Y. We always do G prime of an X value. All right. Vivek?
Number
19 on page MC11. Let me go to a new page. 19 on MC11. Is that a limit one?
Yeah. It was pretty.
There was no answer.
There was no answer? Oh. There was no answer. That tells you something about the question, how well it was scored. So we've got 5 plus 2 to the x. Pardon?
On the test, if I don't know, I'm gonna put T for bride.
I'm not sure that's a good way. At least try to get it down to 50-50.
Yeah, for Chem, I put T for Hollywood.
All right. Now, let's go back over this. Horizontal asymptotes using calculus are limits to infinity or negative infinity. Okay? So the first thing we're going to do is we're going to do the limit as x approaches infinity of 5 plus 2 to the x over 1 minus 2 to the x. If we were to substitute right now, we have infinity over infinity. So what we're going to do is we're going to multiply by 1 over 2 to the x to get the 2 to the x in the denominator. And we're doing that to everybody. So this is going to be the limit of 5 over 2 to the x plus, do you agree that's going to be 1? And then we're going to have 1 over 2 to the x minus 1 as x goes to infinity. Now what's happening to 2 to the x as you go to infinity? X goes to infinity. It's getting enormously large, very, very fast. So what happens to the overall fraction? It goes to 0. So this becomes 0 plus 1 over 0 minus 1. So what's one of them? Y equals negative 1. But we only did what? We've only done one infinity. So now we're going to do the other infinity, which is negative infinity. So we have 5 plus 2 to the x over 1 minus 2 to the x. Let me ask you, what do you know about x's? What do we know about x's? Well, wait a minute. What are they? They're very, very negative. You with me? Very, very negative. So what I want to do is I'm going to do the limit, and I'm going to change my infinity to positive so that I can change my x to a negative so I can see how negative x is. Are you with me? Does that still make x very negative? It can't become positive because x is now going to positive infinity. What is, and I've harped on you all year, have I ever let you leave an answer with negative exponents? No. What does that mean? That means 5 plus 1 over 2 to the x, correct? And this means 1 minus 1 over 2 to the x. Now what happens? This is going to be what? 0. So we're going to have 5, and this is going to be what? Over 1. I think what happened on this is they either did A or C. I doubt anybody did E.
Wait, those turn to 0?
Well, because it's negative infinity. Do you see the negative infinity? So what I did is I elected to put the negative on the x's and make this positive, so that you would see how I got 1 over 2 to the x.
Wait,
Okay, if I kept this as x, you might not have understood why I did 1 over 2 to the x. So, you know what, while we're talking about this, why don't we go to miscellaneous? And why don't we do, hold on. Let's go to miscellaneous number 3, I think. Let's look at miscellaneous number 3, yes.
this one. Why didn't she like multiply things?
Because the x is very negative, meaning I don't need to. It already puts it in the denominator.
Oh, so like I wouldn't have to like.
You only had to do it on the positive because it wasn't in the denominator. Yes?
So anytime you get something like this, variables and exponents, and it's asking for horizontal limits, you have to multiply with the exponential in the
Denominator. For one of them. All right. Yes? Free response? Probably not. This would be more multiple choice. All right. So I want you to look at this free response. How about 10 minutes for you to work on it first?
Ooh, I like these, and then you come around and like.
Ready? All right. Shh. Listen. So the value of r has to be between 1 and 3. It can't be at 1. It can't be at 3 because it's supposed to be in between. But we're on a closed interval to start because they told us it was continuous. So what did the EBT say? Had to be continuous on a closed interval, which we already have. What else? IVT, I'm sorry. Well, I mean, what did the intermediate value theorem say? That it's between two what? Two y values. So the first thing you need is you need a y value at 1, and you need a y value at what? 3. Now, what did they tell us? It's h. So that means this is going to be f of g of 1, and that's going to be minus 6. Now, what do you do from here? You go to your table, you find g of 1, which is 2, and then you got to give me f of 2, which is what? F of 2? 9, and 9 minus 6 is 3. Okay? So you've got the ordered pair 1, 3. So now you're going to do h of 3, which is f of g of 3 minus 6. What's g of 3? 4. Okay, what's f of 4? Negative 1 minus 6 is what? Negative 7. So we've got 3, negative 7. So what are we supposed to do? Explain why there must be a value r. So you would say something along the line, since, what would we say? 3 is greater than, what do we want? Negative 5, which is greater than what? Negative 7. How about since on the interval? Which was what, 1 to 3? What did they ask for? There is a value r. such that h of r is equal to what? Okay, and what's the reason? Intermediate value theorem. If in doubt, what do you say? Continuous. All right, so that's part A. You got 1 point for finding h of 1 and h of 3, and then you got 1 point for your conclusion using IVT. Yes? Because it said that f and g are differentiable. So now let's look at B. Explain why there must be a c such that h prime of c equals negative 5. So they gave you the derivative, correct? So if they've given you the derivative, what do you have to find? I know, but what part of MVT? Okay, let's go back over. What is MVT?
Algebra 1 MVT.
Slope of secant equals slope of tangent. Slope of secant is algebra 1. Slope of tangent is derivative. Remember? So they've given us the derivative. It's at negative 5. So what are we going to do? We need the slope of the secant line. Is it also still on 1 to 3? Do we already have our ordered pairs? So we're going to say negative 7 minus 3 over 3 minus 1 is negative 10 over 2, which is negative 5. And then you'd say what? MVT. Or, if in doubt, continuous. H of t is continuous. All right. You get 1 point for showing this, and you get 1 point for giving them MVT. All right. Now, everybody better... I'm going to be so disappointed if you all cannot do C. How many tests did I put C on? At least 5 or 6, yes. Okay, how do I know it's closed? They didn't tell us closed. Who's messing with you? Okay. All right. So I think the fact that they told us differentiable and continuous, all we need is continuous. So we're good to go. And I'm going to tell you something about this problem when we're done. All right? So what did I beat this into your heads? I mean, seriously. Part B is MVT. Just show this. Show this algebra 1 slope and say MVT. No, that's good enough. Okay? So, now we have f of t. What did they ask us for? W what? Okay, so, if you're not sure, this right here should tell you something. What are they telling you to do? How do we do the derivative of an integral? Yes.
Okay, so you take the top limit, you take the derivative of that, you multiply it by the inside, which you plug in g of x for.
Like this. Is that what you're saying? And that is w prime of x. How many remembered that? I literally put it on just about every single test this semester. All right. Now, are you going to say I'm done? Okay, now what does this tell you to do? Replace every x with a what? So you see, if I'm not sure, when I write this, I look. What does that tell me to do? Do g prime of 3 times f of g of 3. What's g of 3? 2. What's g prime of 3? Is g prime 3? Is g prime? Okay, so g of 3 is? I'm confused. G of 3 is 4. G prime of 3 is? Okay. What is? F of 4 is negative 1, so what do we get? Negative 2. You get 1 point for the chain rule. You get 1 point for the answer. All right. Now, look at part D. We have just done this. What are they asking you for?
Inverse.
Well, it's all about an inverse. That's correct. But what are they asking you for? Equation of a tangent line. What do you need? Point and slope. All right? Now, they have given you They want it at x equal 2, right? X equal 2. Can you tell me what g of 2 is? 3. Okay, so let's start our table. Start our table. Yes.
Why don't you, why is that considered an inverse x?
Which one?
Like the x equals 2 because it's
Oh, maybe it is. What is it saying?
y tangent to the graph of y equals g.
JK.
Sure about the JK?
No. All right, g inverse, or g is the inverse of function g. Write an equation for the line tangent to the graph of y equals g prime at x equal 2. Yes.
If we did something like made a silly mistake like that, and this was what I got confused with that, would they like read with us?
It all depends on the question. So this is g inverse. So that is correct. We have g inverse x value is what? 2. Which means g's y value is what? 2. Now how do you find g's x? Okay, how do you look at the table though? You look for a y value at 2 under g, and what is the x value? 1. Now what do we want? What is the derivative of g at 1? It is 5. So what is the derivative of g inverse? 1/5. What is my g point, inverse point? Okay, so if I want, my point is 2, 1. My slope is 1/5, a dd. The very first two? That one. Or this one, correct? Okay, so you're going to look under g of x column for that 2. So go to your g of x column and find 2. And then take your finger to the left and find the x. So your equation should be y minus 1 is equal to 1/5 times x minus 2. You got 1 point for finding the ordered pair. Listen, you got 1 point for the ordered pair at g inverse of 2. You got 1 point for the derivative at 2, and then you got 1 point for the tangent line equation. All right. Yes. Okay, because what they're saying is we want it to be tangent to the graph of the inverse. Inverse at x equal 2. That means the inverse is 2. And that's the way we used to do it in the book. All right. Did anybody get 1 point?
What's 1 point for what?
For any of these? For any of this? Okay. Did anybody get 2 points? 3 points?
3 points.
4 points? Okay, are you ready for this? The mean, the average score was a point, not even 1, 0.69. This was the worst scored free response in the history of the AP exam. Do you remember? Do you remember all those worksheets I had with these tables? Do you know what prompted that? This question. Yeah. Okay.
IVT is always going to be your
Absolute max, absolute min.
But IVT and MVT always mix up the two.
Okay.
So you explain like when
IVT, MVT. First of all, MVT must be continuous and differentiable. No, C can be all 3 of them. So, the only one that needs differentiability is MVT. And MVT is the algebra 1 slope is equal to the derivative. Let's do f prime of x. Or slope of the secant line is equal to slope of the tangent line. So one thing that screams MVT is that you've been given a derivative of some sort. There will be no derivative, none, no derivative given for IVT. IVT is saying that there is an x value that corresponds to a y value. okay, there's an x value that corresponds to the y value such that that y value is greater than f of a and then less than f of b, or reverse. It could have been the other way. F of a is bigger than y, which is bigger than f of b. So there you're looking at y values, a relationship in your y values. And if you recall, we did a lot of this first semester, and I made you have to address the time interval over the time interval 0 to 3, and you have to show this inequality in order to get credit for IVT. And I made you do that, and you were amazing. Probably the best year of this. Yes, sir.
So NPT is the only one where it needs 3 differentials?
Yes, only one, and the only one that is going to involve a derivative.
So then, for like A and B, why?
Look at B, H prime.
Right. Okay. But then for A, how do you know that it's asking for?
Because H of R, okay, if I have this is Y, and this is f of x, and f of x function notation is referring to a y. So as soon as you see H of R, that is another name for y.
Okay. And these are problems where it's like explain like the same question, explain why there must be a value there, or like.
Usually it's usually explain why there must be a value R, a value C,
In between.
or why there's guaranteed. Guaranteed is another piece.
So they're always going to give you some sort of interval and say like explain
Yep.
why this would work.
Yep, and those endpoints are always going to be important, the 1 and the 3. For A, we had to do the y values. For B, we needed the y values to do slope, algebra 1 slope. So those endpoints are always going to be important.
So as long as there's an interval and for IVT it's going to be a y value.
Right,
And
E
IVT is going to be a
derivative. Okay, yes. All right, let's see. Would you like a more current parameter? More current years? Okay, the most current is going to be parameter number 8. That's a 2007. Now, there was a DE that had a parameter, I think, in the end. I think we did that one yesterday. Then again, maybe not. All right, so we're doing, do you want to try it first? Okay, so we are on parameter P, oh dear. This is P number 8. P number 8, see what you can do. And I'll stop this so people aren't sitting here listening to nothing. Oh. I'm hoping that everybody did really well on part A of P8. All right, f of x is equal to k, and I'm going to rewrite this as x to the 1/2. Is that product rule? It is not product rule. Why? Because k is a constant. So our first derivative is going to be half of k times x to the negative 1/2. And how do you do the derivative of ln? 1 over x. So that's going to be, so you're done. If you stop here, stop. You've got the point. Yes. That's good. 1 over x is about the work that they need.
So I don't have to do like 1 over L.
No. No. Okay. So now what we want to do is we want to do the second derivative. Is this product rule? No. Because 1/2 and k are both what? So now it's going to be negative 1/4 k x to the negative 3/2. And this is going to be, this is x to the negative 1. So do you agree it's going to be plus x to the negative 2?
Oh yeah.
Stop.
We got one thing.
Okay. You got 1 point for the first derivative. You got 1 point for the second derivative.
So you don't need to move the derivatives to
No.
you know what I'm saying?
You want to do as little algebra as possible. Okay? So now part B, it says, for what value of the constant k does f have a critical point at x equal 1? So critical point at x equal 1, how do we get critical points? We say f prime of x equals 0, correct? Did I show the derivative equal to 0?
You did.
I did. So this is going to be, and I'm going to say equals, now for me, I'm going to have to do k over 2 square root of x minus 1 over x, because I don't solve well in this form. But you want to stop here in a, so you get the credit in case you blow this. You only blow it in this point, so this part. So I have 1 over x equals k over 2 square root of x. Now what am I going to do? Cross multiply. So what did they say x was, by the way? X equals 1. So now we're going to say 2 is equal to k. So,
Two. Square root of 1 gets 1.
okay, yes, sir.
Can you just plug in like at the very beginning of the
Yeah, I didn't think about that.
I did that.
Made it a lot easier, wouldn't it? Okay, so you get 1 point for this, or you get 1 point for this. If you don't have one of those two, you lost a point.
Oh, so you can do the second one?
You can do the second one. So there's 1 point. This is a second point. How many have 4 so far? Good job. All right. So now what does it say? Now you have to, oh, wait a minute. We have to figure out, is this 1 a max or a min? Okay? If you recall, let's go to our second derivative. There was a second derivative test for extrema that said we're going to substitute this in. By the way, what's my k? 2. And I'm going to put that as over, that's square root of 1 cubed plus 1 over 1 squared. So this is a non-calculator. So this is negative 2 over 4 plus 1. Is that going to be positive or negative? F double prime of 1 is greater than 0, which means concave up, which means there is a minimum at x equal 1. So you get 1 point for saying that it's a relative minimum, and in your second test, because f prime of 1 is greater than 0, you have a minimum. Now that was the easiest way to do it because you already had the second derivative. What if the second derivative had been negative? What does it mean the concavity is? And if you're concave down, what do you have to have? Maximum. All right, so there's B. Anybody have 6? Nice. All right. So now let's go for C. It says for a certain value of the constant k, we cannot use k or the 2 anymore. Yes.
So when if it's 0, is it neither?
Yes. Well, if it's 0, that means this test failed right here. I would have to go back and do an increasing, decreasing chart at 1. Okay? No, if it fails the second derivative test, you go back and do an increasing, decreasing chart. Negative infinity to 1, 1 to infinity. Do we have an ln in this problem? So I would do 0 because we can't go past 0. And then I would pick test values like a half and maybe 2. And then I would substitute into here. And what was it? We had a 2 over 2 square root of x minus 1 over x. So actually I would pick 1/4 and I'd pick 4 so I could square root it. So square root of 1/4 is 1/2. 1 divided by half is 2. And then minus 1 over 1/4, which is 4. 2 minus 4 is negative. And then 2, that simplifies. 1/2 minus 1/4 would be positive. So you could have shown it that way, yes.
Okay, so when do you do the second derivative test and when do you do the increasing, decreasing?
I do the second derivative test when A, I already have the second derivative, or the second derivative is easy to do. If the second derivative would be a nightmare, then I'm going to do a first derivative test. Now, if you choose to do the second derivative test and you get 0 rather than a positive or negative number, then you've got to go back to the increasing, decreasing chart.
Okay.
All right, let's do C now. Now we cannot use 2 anymore. We have a new unknown K. We need a point of inflection. What do we know for points of inflection? That the second derivative, and in order to do this, I can't leave it in this form because, okay, that's -1. No, that's going to be negative K over something. 4 square root of x cubed. Isn't it plus 1 over x squared? Okay. That is our point of inflection, correct? So if I were to solve this, I would get K over 4 square root of x cubed is equal to 1 over x squared, correct? So then I'm going to get K is equal to 4 square root of x cubed over x squared. Now what do? This is 4x to the 3 halves over x to the 4 halves. Where did I get 4 halves? 2. So what is this equivalent to? If I have 3 halves on top and 4 halves on the bottom? -1/2, which means 4 over square root of x. So that is my K. Agreed? What do we know about the first derivative? Where do the points of, okay, if I were looking at a first derivative, how do I find points of inflection? When I change from increasing to decreasing or decreasing to increasing. And what did we determine in B that we had? We had a minimum, right? So do you agree that the maximum, the minimum is going to be a point of inflection also? The same point of inflection. I should say the minimum on my first derivative. Does that make sense? Or not? Okay. We want a point of inflection. What did they tell us about K? They said the function is defined to be greater than 0 where K is positive. Have we talked about K being positive?
They obviously say for a reason, though.
I'm missing something. F of x equals, for all x greater than 0, where k is a positive constant. Oh, here it is. Read it again. Where is this point of inflection occurring? How many people highlighted on the x-axis? What does that mean? Does x equal 0? Oh, there's your second equation. So you've got to come up here and we've got to get y. What's your y function? You're going to say 0 equals k square root of x minus ln x. Do we have an expression for k?
Yep.
Can I put that in there?
Yep.
So 0 equals 4 over the square root of x times the square root of x. Look at that. Those are simplify. So I'm going to have 4 minus ln x. I'm going to add ln x. How do we solve this? E to the 4th is equal to x. What do they ask for? Okay. Oh, if I have x, can I get k? Okay, Aditi. This k? Okay, we set the point of inflection means second derivative equals 0. So I set the derivative equals 0 and k equals this and I simplified it. Shh. Now listen. Let me ask you a question. Did you set the second derivative equal to 0? Yeah. If you could not get any farther than that, you have a point. Remember, it's all about the derivative equals 0. All right. If, now listen, if you were able to get this far, where you substituted for k, and let's say you couldn't solve past there, that's your second point. So now that we've got this, we're going to come back up. Oh, that's not a pen. We're going to come back up here, and we're going to do 4 over, what's the square root of e to the 4th? E to the 2nd. That is your third point. Oh, just kidding. You definitely would leave it this way. You got your, yeah, don't try to square root e to the 4th. You got your point right there. All right, so here, hold on. Once I get to here and here, I have my derivative. I'm not going to do anymore. Now, when I got over here, I had to solve. For me, I don't do negative exponents in solving equations. So I needed to go further here. But whenever you have all numbers, you can quit. Yes? Yes, Michelle.
Hey, why did you do that? That.
This right here?
What are you looking at? That.
Right.
Yeah.
Okay. Look, go to C.
I read it.
It says, for a certain value of the constant k, the graph of f has a point of inflection. Where is it? Where's that point of inflection? That means this concavity is changing right there. What's the y value on the x-axis? 0. On the x-axis told you that. So subtle.
But like, your head is like all over the way. But why did you do that step? Like, if like the x-axis. Like that's
All right, why? All right, this is the issue. Do you see this? I have 2 unknowns, and I can't solve when I have 2 unknowns unless I have 2 equations. So there's got to be a second equation. And that second equation has the fact that it is on the x-axis where that point of inflection occurs. Therefore, that means y equals 0. That's equation number 2, which means now I can substitute my k in there, and I'm in one variable, and I can get where I need to go. When you have 2,
Okay.
when you get down to 2 variables, you're going to need 2 equations.
Okay, so you did that because.
It's on the x-axis because I needed a second equation, and on the x-axis is telling you. And that was so subtle to miss. Pardon?
What happens if I don't do the second equation, but I just do the first one? Do you get like 2 points?
You got 1 point. Because you had to get it into one variable. It says equation in one variable. So that means you had to at least get to here. You had to substitute. All right, hold on. Someone asked me to go over this. Okay? Someone asked me to go over this. Derivative of an ln function is 1 over the function times the derivative of the function. So if I want to take the derivative of ln of the square root of x, then that's going to be 1 over the square root of x times the derivative of square root of x, which is 1/2 x to the negative 1/2. And this is, on the AP exam, you stop. You have the credit right there. Yes. Now, if you have an LOG, we do change of base. Okay, you do change of base. So that means we're going to do the derivative of, and our change of base is 1 over ln b times ln of the function. Now, what do we follow? Those rules up there. 1 over the function times derivative of the function. Let me give an example. Suppose we have log base 3 of, we need a function. Let's do sine 2x. I thought so too. All right, so what does that mean? That means, first of all, we're going to change this into 1 over ln 3 times ln of sine 2x. All right, so what do we do? This is going to be 1 over ln 3 times 1 over sine 2x. Now, when you do this derivative, it is a chain rule. Derivative of sine, cosine of the angle times the derivative of the angle, which is 2. And you can stop. You're done. Yep. Yes. Okay, yes.
Why couldn't you go just because I know that when we first we said 1 over ln of the base times ln of the function
Times 1 over the function times derivative of the function. You're fine.
Why would we have to?
You wouldn't have to if you remember that. Now let's do exponential. Yeah, let's do the exponentials first. Yes. So for this exponential, notice it is not just e. It is any number, any base, all right? So if you remember, this was ln of the base times the function just as it appeared times the derivative of the exponent. So I'm going to do a couple examples of these. I want to talk a little bit more about those logs. So if I want to do the derivative of 4 to the x squared, then it's going to be ln of 4 times 4 to the x squared times what? 2x. Done. Don't do any more.
So you don't need to combine any of those?
No, because it's on the AP exam. You got credit. Yes.
Can we go over the change of base?
E to the, we'll do tan x. Okay, so this is going to be ln of the base times e to the tan x. What's derivative of tan? Secant squared x. Done. All right. What did you ask me to do? Caleb? Oh, change of base. Okay, so if I have log base b of d, that might know. How about h? Change of base is 1 over ln b times ln of the expression here. Most people write ln h over ln b. I write it this way because that's coefficient and that needs to be done with the derivative.
But when you do that, do you have to ln the other side of the equation?
No, there's no. That's a change of base. That means that this expression right here, there is no equation, is equal to that.
Wait, that's the derivative?
No, it's not a derivative. That's change of base. This is a derivative.
That's the derivative.
Yes, about exponential. Someone asked me about the integrals. All right, if we have an integral of an exponential, some number, it must be to the x. It cannot be anything other than x. And this is going to be 1 over ln of the number times that number raised to that x plus c. If this is anything other than x, it requires u substitution. So if we want to integrate something like, let's integrate 8 to the x squared, I'm changing it as x times 8 to the x squared dx. So that is not just plain x. So we're going to say u equals x squared, du equals 2x dx, dx equals du over, all right, so this is going, yeah?
Don't you want to separate it though, like 1 over 2x?
You can. So we've got x, we've got 8 now to the u, and we've got du over 2x, and what can we do? That x goes with that x. What can I do with my 1/2? So we've got 1/2. We're going to arrow. We're not going to equal, are we? If you go sideways, don't ever put an equal sign. It's all going to be about what? Arrows. Why?
Because then
You avoid lethal.
whole linkage.
So this is going to be 1 over ln of the base times the function as it appears plus c. And that's going to be 1 over 2 ln 8, and you got to substitute back, which is h is the x squared plus c. All right, then we never integrate ln. If you have an integral with ln in it, that means ln is going to be u, guaranteed. You didn't learn how to do that. What we did learn how to do is we learned how to do the integral of 1 over x dx. And what is that? Ln absolute value of x plus c. Now, if this denominator, it has to be to the first power. Not the second, not the 1/2, not the 3/4. It has to be to the first power. If what is to the first power is anything other than x, it's going to require what? U substitution. All right. Yes. Sure. This is your review. I'm just here for you. We're on MC3, number 6. Number 6, M3. Ooh, we've got a piecewise function. They like piecewise functions. Oh, there's no 6 on that, is there? They left off the 6. Question, what does this mean? X is greater than 2 and less than 2. When I'm on a piecewise function, I like to look at my functions. I got a function on the left, which is this. I've got a function on the right, which is this. And what do we know about that one? That one is just at 2. So let f be defined above. All right, does this have a limit at 2? How do we figure that out? So we're going to do the limit. Do I have to do a left and right limit, or can I just do one limit? Are they the same? So if I do the limit from the left and the right, am I working with the same function? But what do we have to do to this function? If you get 0 over 0, what's true? So this is going to be 2 plus 2, which is 4. Does it have a limit? Yes. What is the limit? What's the y value? It is 1. Is this function continuous? Because what are the 3 questions? Is there a y? Is there a limit? Does a y equal the limit? All right. That's where we are in pre-calc. All right, so number 2 is not. Number 1 is. Differentiable. How do you figure out differentiable? You have to do the derivative of the top and the derivative of the bottom. Here's a hint. You see how we simplified? All right? We can do the derivative of x plus 2 rather than this whole thing. If we did the derivative of the whole thing, it would simplify to x plus 2. So what's the derivative of x plus 2? 1. What's the derivative of 1? Is the derivative from, are the derivatives equal? No. Oh my gosh, that was stupid. Okay, anyway, if it's not continuous, the derivative can exist at 2. Therefore, we already knew part 3, but just in case you needed to know how to do a derivative of a piecewise function, you have to do the derivative of all the pieces, and they have to be the same once you substitute in your number. All right, yes? It's not continuous because the y value, which is 1, is not equal to my limit. Okay. And this prompted me to think of something else, and I just forgot it. So, Julia? Okay, so domains. Okay, what are your 0 issues? X in the denominator. Okay? Negative issues is when the denominator equals 0 or logarithms. Logarithms have negative issues or 0 issues. Negative issues. are your even roots and your logarithms. Logarithms cannot be, the expression of a log cannot be negative. Those are the only ones. Okay, what do you want? You want a logarithm? You want all of it? So if we have y is equal to the natural log of x plus 3, whenever you have a negative or a 0 issue, you always take the expression and set it equal to 0. So x equals negative 3. If you recall, I asked you to do a table, correct? Negative infinity to negative 3. Why did I ask you to do a table back in the day? What was I preparing you for? Chapter 3. Test values, negative 10. How about 0? We're substituting into x plus 3. So negative 10 plus 3 is negative. 0 plus 3 is positive. We do not want the negative side. This is how we dealt with the negative issue. The table is all about the negative. So now when I go to do my domain, we know infinity always takes a parenthesis, correct? The 0 issue always takes a parenthesis. So the 0 issue is dealt with the parenthesis. Does that help? Okay.
So if it's just 0, the only thing you do is set the function equal to 0.
Yes, if it's just a 0. Shaya, your hand went up first.
Okay, can we go to M14 and to the F? I know we did it like you said.
M14. M14, yeah. Okay. So do you want me to do it?
Yeah.
You don't want to do it to have time?
I've done it, but
Okay. M14. Miscellaneous number 14. All right. I graded this one. All right. So let's look. Let's go to a new page. It says, so let's do the reading. Grass clippings are placed in a bin where they decompose. If these are decomposing, what do we know? It's decay. Decay means what? Decrease, right? There should be something should be decreasing here. Now, they've given us a closed interval. What should we be thinking? Am I doing my reading like I should be doing my reading? So I'm thinking intermediate value theorem, extreme value theorem, absolute value theorem. So for the closed interval, the amount of grass clippings remaining in the bin. So the next thing we have to figure is A of t, oh, this is a calculator one. Is A of t a original first derivative or second derivative? So it says amount of grass clippings. That lends me to believe it is a original. But I'm going to read further. A of t is measured in what? Right there it is. To be a rate, what must be true? Pounds per something. All right, this is not a rate. This is not a derivative. T is measured in days. All right. So then it says, find the average rate of change of A of t over the interval 0 to 30. All right, that word average. Average rate of change means what? It is algebra 1 slope. How do we know it's not derivative? Derivative is at a point, not on an interval. Does that make sense? So we're going to have to, first of all, find A of 0, and then we're going to have to find A of 30. Yes? They want an average rate of change. All right, so that because of the word rate, we know it's a derivative. Because we know that we were at pounds, we're not at a derivative, right? So we want an average rate, which means a derivative, so I'm going down a level. If they wanted average pounds, we're at the same level, then we would. All right, where's my calculator? So the first thing we're going to do is we're going to go to our calculator. We're going to clear this, and we are going to put in 6.687. And then we're going to put in times 0.931. Oh, goodness. This is so annoying. Let's see, did I do it? All right. 931 And that is going to be to the what power? Raised, come on, to the x. All right. Now, what's my time interval? 0 to 30. So we're going to go to our window. We're going to make that 0. And what are we going to make our other x? 30, because that's what we want to see. And I'm going to hit graph. Now, what did we say when we were thinking aloud that this function should be? Is it decreasing? Okay. So, if I do second trace, what's the plug and chug feature? Value. So you're going to choose number 1 and you're going to put in 0. We need the plug and chug, not the integrate. So that means that my y value here is 6.687. If I'd thought about that, I should have known that. And then you can type in 30 and get your other y value. Are you with me, Shreya?
Yeah.
Okay. Was this a problem yesterday? Okay. 2,92787. So I think what I didn't do yesterday is I'm going to go ahead and quit this. I truly am going to quit sometime. All right, quit this, and I'm going to go to store, and I'm going to store this in alpha A in case I need to use it later. So this is what I'm going to do to remind myself. Oh, well, that didn't do it. Oh, look at that. What happened? Oh. Okay, why can't I do this? Do you know why I couldn't store? It's a y value. All right, so anyway, it's there. I'm still going to go ahead, and I'm going to put 0.7829277. Did I type it right? 7829. Nope. So when you type something in the calculator into y equals, what are you going to do before you do anything? You are going to double check it at least 2 or 3 times. 7, this will be online, Adam, if it doesn't crash on me, okay? So I'm going to store this in alpha A now. Enter. Because it was a y value. It will only store the x values. Yeah. So I'm going to make a notation that that is A. All right. So now I have to do what? I have to do the average rate of change now. Can I do it? I'm going to do A minus 6.687. See, that saved me from having to write that all over again. Over 30 minus 0. And what are we going to do? We're going to stop right here. This gets us the point, and we are going to write with units pounds per day. We are done. We get 1 point for this difference quotient. We get 1 point for the units. If you went ahead and did that, by the way, it is going to be approximately negative 0.197 or 196.
So you don't get points for the actual, like, the actual answer.
Yes, you will get a point for this if you said pounds per day. Okay? But this is the deal. Okay? Aditi stopped here. Okay? You were a show-off, and you decided that you were going to go ahead and do this, and you got negative 1.97 pounds per day. What did you do? You had a copy error when you were taking it out of your calculator. So you see, Caleb, what happened is you earned a point here. And you just lost it because that's wrong.
Do you get points for units?
And sometimes you get points for units. In this case, you only let's say you decided that your answer was let's say your answer was this, and this is all you gave. You lost the point because they want the units with the number.
What about with the A too? You can do the A too, and they want the A?
You can do the A because have I shown them what A is?
You have.
I have. So that truly is a number. All right? In this case, did they say using data from a table? No, they did not. So Ariel said, could I have said a of 30 minus a of 0 over 30 minus 0? Yes, you could have. Okay?
So you don't even have to do it.
Well, if you do that, I think they're going to want, hold on, let me pause this.
You don't even have to do it. Do everything.
Okay. So the question is, if this is all I did in green, you got 0 points. If though, now listen, if you said equals negative 0.197 pounds per day, you got your point. Okay? In this case, because this is abstract, you needed the answer. However, if you have this, you didn't need this answer. You got the full credit as long as you had the pounds per day with it.
What's the difference though? If you show them that a of 0 equals that and a of 30 equals that.
Because they want to know, can you use your calculator?
No, like
Yeah,
what if you wrote that? Like Ariel wrote that, right?
Did you write this too, Ariel? Oh, so she got the point.
No, she wrote these. What's the difference between that and like?
Oh, now you're going to make it hard. This is one of those ones we'd have to go to the table leader on. Read, no calculator.
I'm trying to give Ariel her full credit.
I am thinking that if
She's like,
I'm thinking that if she said what a of 0 was and what a of 30 is, I'm thinking that you would have gotten that point. Let's put it this way. As a reader, I would have gone up and to the table leader and I would have fought for that point.
Thank you, Mr.
Because you basically have shown, so yes, I mean, I don't even think I would have to go to the table leader, and this is why. Because you have named this point a of 30, you've named that value a of 0, so it's there.
If you're like saying that that's a too, like.
Okay, so my point is, if all you have is green and nothing else, you will not get the point. You do not have these. You do not have those, okay? All right, so now we're moving on. Part B, it says find the value of a prime of 15. What does that mean you're supposed to do? But do you have to find the derivative? Why don't you have to find the derivative? It's a calculator. So we're going to go back to second, trace, and we're going to choose which one of these now? 6. Yes. You probably could, but I think if I already have it graphed, then I can just do everything from here. So I don't want to choose, what am I supposed to plug in? So I'm going to plug in 15. Now let's talk about what we just got. So if you want this credit, this is part B, we got to let him know that a prime of 15 is equal to negative 0.163 or negative 0.164. Yes?
How do you like know what to do with the statistics? Like, when do you know to write everything out or just?
If you write everything out, we stop reading at the third.
Oh,
And if anything past that is wrong, we don't even acknowledge that. Okay?
so
It's safe to write out all of them. Yes. Yeah, I already had my function in. Okay? So I go to second, trace, dy over dx.
So you wouldn't have to put in the y equals.
My y equals is already there.
Oh, okay.
I did that in the beginning. Okay. It's just been a long time. So now, it says, interpret the meaning of the value in context, quiet. You have to be in context of the problem. So here we go. What does this mean? This means that at t equal 15,
What's the units for that?
well, I'll do that in a minute. At t equal 15, a prime, the number, or maybe not number, the amount of grass clippings, how do we interpret the negative? Was decreasing at a rate of 0.163. What is it? That would be pounds per what? Day. All right. How do kids mess this up? They put a negative here because I said decreasing. You cannot have a negative here because that means increasing.
What if you don't put, so if you say decreasing of a negative, that'd be like increasing.
Okay, that's one way. You put the rate too soon. You say the rate of the amount of grass clippings. Then you're saying that A prime of 15 is decreasing. It's the amount of grass clippings was decreasing at a rate of, yes.
So you have to acknowledge that the amount of grass clippings is decreasing. Could you say that the rate of Could you say that the rate of the amount of grass clippings is negative 0.163, or is that not good enough?
You didn't.
Like, to just forego the whole decreasing thing and just say the rate is this, but say the amount of grass clippings and all that stuff.
Okay, this was, oh my gosh, this took a long time to grade. All right. First of all, you have to have the time. You have to have the units.
Right.
And you have to have this. And you have to have the word rate. If you put average in there, you missed it.
So if you just
all right.
The rate of grass
You can say amount is decreasing. You can say amount is decomposing. The amount is shrinking. The amount is changing. You could have said the amount of grass clippings is changing at a rate of negative.
Right.
Okay.
But you couldn't just say like the rate of the amount of grass clippings is negative.
All right.
You can't do that.
The rate of change.
Is that what you did, Julia?
Instantaneous rate of change, average rate of change, rate is decreasing. If you have rate before decreasing, bad.
But if you didn't include decreasing, you just said the rate is this.
The rate of what, though?
You said the rate of the amount of grass clippings is negative 0.163 pounds per day. Is that good enough, or does that not explain the meaning of it?
No, it's changing.
Part B continued. I'm not sure.
So just stick with.
I would stick with this. But instead of decreasing, use the word changing at a rate, and then use your negative sign, and you're good to go.
Okay, you don't even address.
Right. Yeah. Now, I said at t equal 15, you could say on. Oh, let me get another pen. Let's talk about, these words are important. You could say on. What you cannot say is over, during. You can't say after. You can't say around. You use any of those words, you lost that point. Okay?
But you can say it, so if you're going to say it's changing rather than saying so you say the amount of grass clippings.
The amount of grass clippings was changing at a rate of negative 0.163 pounds per day. That's the safest way to do it. Okay? And remember, it's got to be at t equal 15 because a derivative is an instantaneous rate of change. All right. Now, let's go to C. Yeah. Instantaneous is derivative, yes. All right. Did I pause that? No, I didn't. You ready? Part C. Part C is find the time t, so I'm looking for t, which the amount of grass clippings in the bin is equal to, so average, if I look at average for which the amount of grass clippings, do you agree that's A of t? We want that to equal the average amount of grass in bin, and it's on an interval 0 to 30. So here is that word average. Is it algebra 1 slope or is it average value? Next thing we're going to look at, it's the amount of grass. amount of grass. What is A of t? What does A of t represent? The amount of what? Grass. So we want the amount of grass to equal the average amount of grass. Have I changed levels? Do I want to know the average rate, the amount of grass? It's the same level, so what do we need? Average value, 1 over 30 times the integral from 0 to 30 of our A of t dt. Now again, I want to go back through this because I want you to be able to play with units. A of t is pounds. dt is days. That makes absolutely no sense. But remember, 0 to 30 is days. So that's 1 over days. And what happens? The days cancel. Will I be in pounds amount of clippings? Yes. So what are we going to do? We're going to go to our handy dandy calculators. Do I already have my function? So now what do I have to do? Second trace, which one? 7 from 0 to 30. Now, this is going to give me, come on, what is this? Which side of the equation does this give me? This is 82 point, is that a 579053? Right, so we've got 1/30th, which means I have to divide by 30. Okay, now we want to know when is the y value on A of t that number. Okay, you with me? So how am I going to do that? So watch how I'm going to do it on the calculator. So I'm going to go to my y equals. Actually, I'm going to do second quit. Second quit. Darn it. Okay, so I'm going to store the answer I just got, which is 82, in B. Is it that right number? Okay, so I stored it. So now I'm going to go to y equals, maybe, and I'm going to go down here, and I'm going to type B divided by 30. Look, I got it right there. 82 divided by 30. Now, if I go to graph right now, you still see the shading. Well, I don't want to see the shading. Do you know how you get rid of shading? You're going to come here and just retype over one number, and it will regraph it. So, where is my y value? This number. Right there. So what are we looking for? The intersection. So did you just learn something? So we're going to go to 5, and we're going to get our cursor close, and we're going to hit enter. No, enter. There we go. Enter, enter. And what is it? It's at 12.414. What is that? 7? Okay. So you get 1 point for this expression. Hold on, let's find it. It's all buried. You get 1 point for saying A of t. I should have finished my expression. A of t is equal to that. That is 1 point right there. Okay? Actually, that's 2 points.
Wait, isn't that? Oh.
Wait a minute, I'm looking at the wrong one. You get 1 point, I'm looking at D. You get 1 point for your integral, which is this right here. That's 1 point. And you get 1 point for this.
But how's the average equal to
Okay, look at this. I had pounds times days, and then 1 over 30 I divide by days. So this side is truly in pounds. Because I don't know what causes things to decompose, but maybe we have a really hot day for a week and then we get a really cold day, I'm guessing things don't decompose as much in cold weather. Does that make sense? So over the 30 days, the average is going to be different than what's happening every single day. Yes?
So, on our paper, we would write that integral, but then we would say t equals 12 point whatever.
Yes. All right, yes. Wait a minute, we have to finish D.
Oh,
Yeah, because I want you to look at D because it's a linear approximation. Okay, so the question is, let's go back on average value because I really want you to understand this, all right? When I see the word average, I stop and I say, which is it? So when you read it, it says the amount of grass, that's A. Are you with me there? All right, in the bin is equal to the average amount of grass clippings. They didn't say the average amount of grass clippings per day. That would be a rate. It's grass clippings. Do you see that there is no per?
so we need to
Okay, so that means that the average amount of grass in the bin and A of t is, all of these are both grass. Neither one of these is a derivative. So if I need the average amount of grass, I'm staying at the same level of grass. Therefore, it's average value. If it had said average rate of change, then I'm going down one, it would be algebra 1 slope. Or if they said average pounds per day, that pounds per day tells me rate. Okay, so now let's look at D because, yes?
But same, you're still going to use an integral just because it's average value.
When you're same level, you will be using an integral, you'll be doing the average value integral. And the reason why is because this part of the average value will always cancel that part, so you stay there. Okay? All right, part D. Part D says for t greater than 30, because what happens if we look at this, if we look at our function again, I gotta turn this on. When we get past there, do you agree that it's a whole lot linear? It's not changing very quickly anymore? So what they're saying is they're saying that bigger than 30, the linear approximation to A at 30 is a better model for the amount of grass clippings remaining. So linear approximation, when you see linear approximation, they're talking about tangent line approximation. And what do you need for a tangent line approximation? A point and slope, correct? And our point, they said at 30. Did we not find its y value earlier? Remember I stored it in A? Okay. There's my point. Now, I am going to need the slope. So what slope do I need? The slope where? At 30. Well, how am I going to find that? I'm going to go here. How'd that turn off? Oh my gosh. This does not have batteries. It cannot. So do I need this in number? Do I need Y2 anymore? So I'm going to clear that. All right, so I'm going to graph it. I am going to do which one? 6. And what am I plugging in? 30. And what am I finding? The slope. So my slope is going to be negative 0.05597762. So I'm going to say this is equal to, label what you found. What did I just find? A prime of 30. And that is my point. So my equation now, did I tell them what my A was, by the way? Up here? I did. So I'm going to say y minus A, is it y? Yeah. Is equal to negative 0.05597762 times t minus 30. So there's my tangent line. So use this now to predict the time. I'm looking for time when there will be half a pound of grass remaining. Where do I put the half a pound? In for what? Y. So I need 0.5. Minus A is equal to. So what do I do to go about solving this?
you use plug in A that you already have stored
What will I do? I'll do this subtraction, then what'll I do?
Divide by -0.05.
-0.05599762. So do you agree that'll be gone?
Yeah.
So let's go here. Let's do second quit. And we're going to do 0.5. No, I'm not using, darn. All right. So I'm going to do 0.5. Since I didn't use parentheses, I'm going to enter in a minute. I'm going to say subtract the A value that I stored. Store, all right, store A. And I'm going to hit enter. And then what do I do to that? Divide by negative point 0.055999762, and I'm going to hit enter, and then what will I do? Add 30. Darn it. All right, so we get 35.0544. So you get 2 points for this expression right here. Okay? You get 1 point for literally putting 0.5 in for y. If you did nothing else and did not solve, you got a point. Pretty good, isn't it? And then you're going to get 1 point for 35.054. Yes? I would probably say t equals. You could circle it. Your hand is up first.
We have a multiple choice.
Okay, just a second. Any more questions on this? Okay, multiple choice. I did it wrong.
I don't know. Yeah.
Okay, MC what?
I don't know if it was for 18.
Okay, so we said the answer was -3. No, someone says the answer -3, Mrs. Bride. Okay, let's look at it. Let's go back.
Oh, this was our first one we went over.
No, we just did this.
Did we just do it?
Yeah, we just did this.
Very first one for the day?
They were here. No, wait. No, we were here. Oh, you were 18? No, you were never. I said you were here.
You'll be already
Karen, there it is, right?
Yeah, we already did this.
I know, she's saying the answer was wrong.
Or
Oh, well, that's not it. So I've done it, so let's go back and look for it.
Then why do we have -1?
I don't know.
You're wrong.
I'm wrong.
I just, is this it?
Yeah, we were here. No.
That's it. No, because we got x to be -2. What did we do? So now, so you get x to be -2. We've got y to be -1. K equals -3. I just did it verbally.
Wait, you get 2 questions?
Are we 20 on page MC 12? Okay. Now, it says let f be a function whose second derivative. Now notice they've given you the second derivative. This means that they're looking for you something about the second derivative. If you had to find it and you messed it up, then they wouldn't be able to test whatever they're testing. What are the x-coordinates of the points of inflection? So what do we do first? 0 equals x squared times x minus 3 times x minus 6, or x equals 3, x equals 6. Now, we have to do -infinity to 0, 0 to 3, 3 to 6, 6 to infinity, right? -1, 1, 4, 10. And I'm going to, what do you know about this always? This is where we work smart, not hard, so I'm going to substitute into this. So here we go. Negative minus negative, negative minus negative, negative times negative is positive. 1 minus 3 is negative, 1 minus 6 is negative, I still get positive. 4 minus 3 is positive, 4 minus 6 is negative, I get negative. 10 minus 3 is positive, 10 minus 6 is positive, positive. Remember, points of inflection only occur when And there's only 2 sign changes. And if you did not do that, you would have said 3, and they would have gotten you. Yes.
You look at it, go.
So we're on MC 14, number 24. This is, I think, another linear line thingy. It says we have twice differentiable. We have f of 2 equals 1. We have f prime of 2 equals 4. And we have f double prime of 2 is equal to 3. All right, they want you to use the line tangent. So what do you need? You need a point and you need slope. All right, what's your point? What's your slope? Why isn't it 3? That's double prime. So you're going to have 4 times x minus 2. Are you with me? Now, using this, substitute in your 1.9. So you have y equals 4 times, that's going to be negative 0.1, plus 1, which is going to be 0.6. Okay? Yes, sir.
Okay, so go for number 1.
On?
The first one.
On the very first multiple choice. Uh-huh. Because they said, I think they said, this is 24, right? They said, what is the value of the approximation? Right there is a clue of f of 1.9 using the tangent line to the graph of f at x equal 2. So the fact that they said at x equal 2 means we're supposed to use a 0.21, get our equation of our tangent line, and then approximate 1.9. We plug, wait a minute, we plug this is the tangent equation. This is the tangent line. That's what we substituted it into. Okay, we are doing number 1. Yes? You don't. They wanted to see if you understood that the slope of a tangent line was first derivative, not second. That's what that was one of the things they were testing. And to see if you understood approximation. All right, so number 1, the very first multiple choice, this is the issue. First of all, it is what? In factored form, correct? And we have limits going to what? Okay. Let me show, I can talk to you, I can show you L'Hopital's rule if you want. That's pretty clever. All right. So normally we would do 1 over the highest exponent of x in the, this is number 1, very first multiple choice. Normally we would do 1 over x, highest exponent of x in the denominator, correct? What's the highest exponent of x? X squared. Why is it x squared? So if you FOIL, this is going to be 6x minus 2x squared minus 3 plus x all over x squared plus 3 minus 1 plus 2x minus 3. Now what are you going to do? No, it's infinity. 1 over x squared, 1 over x squared. So you're going to have limit of 6 over x minus 2 minus 3 over x squared plus 1 over x, right? Yep. All over 1 plus 2 over x minus 3 over x squared as x approaches infinity. Now, when this gets really big, what's happening? 0 minus 2 minus 0 plus 0 over 1 plus 0 minus 0, which is negative 2. Okay, let me show you something really slick. Yes. So what if you had the limit of x squared minus 4 over x minus 2 as x approaches 2? What happens if you substitute right now? 0 over what?
The answer would be 0.
So there's this thing called L'Hopital's rule. I think it's like El Hospital. I think that's L'Hopital. Maybe there's not an S in it, but that's how I remember it. All right. Anyway, so L'Hopital's rule says, all right, we have a derivative that gives, a limit that gives us 0 over 0. What's the derivative of the numerator? What's the derivative of the denominator? 1. Can you substitute 2 in now? What do we get? 4. Okay, let's do this the old way. This would be x plus 2 times x minus 2 over what? X minus 2 as x approaches 2. That simplifies. Substitute. You get 2 plus 2. What do you get? We didn't do this initially because we did not have derivatives when we learned it.
Wait, so you can use that for any limit?
How would that work with infinity, though?
Okay, this is for 0 over 0. Okay, let's do infinity.
This is Brad.
Yes.
So like, can you always use that? The loopy hospital.
Only if you get 0 over 0.
Okay.
Now, let's see if it works on infinity over infinity. You ready? What if we have x squared plus 4 over 2x squared minus 4, limit as x goes to what? Infinity. Okay. Well, I don't know. So we're going to do the limit of, what's the derivative? 2x over 4x as x goes to what? Okay, what simplifies? So what's the limit of 1/2? 2 over 4? 1/2. If we did 1 over x squared, we would have limit of 1 plus 4 over x squared all over 2 minus 4 over x squared as x goes to infinity. What do we get? Oh my goodness. Uh-huh.
Wait, what's 5 over 0?
5 over 0, it's undefined. Limit doesn't exist.
How about
0 over 5, the limit's 0. Yes. Related rate with angles. I don't know of one in here. I don't know. No, I'm not. I'll stay here to 5. Depends on you all. Or till the last person leaves. 5 or when nobody's here, whichever comes sooner. All right. That's application. I need 2.6. Where's 2.6? So the question was, how do we do a related rate trig? Okay. So here's a related rate trig. Related rate trig. Angle of elevation. Okay, you ready? A balloon rises. There's my balloon. Here's my ground. At a rate of 5 feet per second from a point on the ground, 40 meters from the observer. Oh, here's a point on the ground. This is 40 meters from this observer. There's our person. He sees a balloon, okay? So find the rate of change of the angle of elevation. So this is going to be our angle of elevation. So we're looking for this. Angle of elevation when the balloon is 30 meters above the ground. Do you agree that the height of the balloon is changing? Do you agree that this distance between the observer and the balloon is changing? Yes? Okay. So, do you agree that this never changes? Okay, so we can use 40 now. What did I ask you to do? Write all 3 trig functions. Sine theta is what? Opposite over hypotenuse. What is cosine? Adjacent, which is 40 over d. And what is tangent? It's going to be opposite over adjacent. Now, do you want to work smart or work hard? So we're going to eliminate this because those, you can do that, because those are both variables. Now, which of these do we choose? The question is, are we given the rate of change of D, or are we given the rate of change of B? The balloon rises at a rate of 5 feet per second. There's our rate. Is that dB or dd? That is the rate that the balloon is rising. That means we want this one. So from here, okay, we set up all three trig ratios, eliminated the double variable. Then we said, which rate are we given? The B, not the D. We're given the rate that the balloon's going up. We're not given the D rate. So we don't want this one. So now what's the derivative of tan? Secant squared theta what? D theta over dt is equal to, that's going to be 1/40th, and the derivative of b is 1d b over dt. All right. 5 feet per second, is that positive or negative? That is positive because the balloon is what? Rising. The balloon is now 30. So can I put, oh, I need secant. How do I get secant? What's the ratio for secant? Reciprocal of cosine, which is hypotenuse over adjacent. So if this is 40 and this is 30, what's D? You all know this. 50. 3, 4, 5. How would we get it? Pythagorean theorem. So that's going to be 50 over what? 40. And what is that? 5/4. And what do I have to do to 5/4? So that's going to be 25 over 16. And that's going to be d theta over dt. Now can we solve for d theta over dt? So that's going to be 16 over 25, gone. 16 over 25, so d theta over dt is equal to, that goes in there 5 times, 8 goes in there 2, 8 goes in here, is that 2/25? And that is going to be angle, radians per, I don't know what the time units were, second. Right, remember it's an angle. Oh, a lot? Not a lot, no. Wait a minute. I thought secant. Opposite over hypotenuse is sine. Okay, Julia?
What we have to know how to do is relate the rates that are like with the cylinders and the cones.
Okay, I think you will probably prefer a cone because the cylinder is going to be more straightforward. And the cone had a what? What was the trick on the cone? Proportion. So where is the cone? There it is. So you ready? We have a conical tank with vertex down. And we have, it is 12 feet across. So what is the diameter? I mean, what's the radius? Okay. And it is 10 feet deep. This is a tank. Will these yellow dimensions ever change? No. Now, we have water that's flowing into the tank. This is going to be R. This is going to be H for height. So the first thing we're going to look at is our proportion. So we know large R is to small r, as large height is to small height. So when you cross multiply, you get 6h equals 10r. And we're going to stop here. So what's going on? We have 12 feet across. If water's flowing into the tank at a rate of 8 cubic feet per minute. So we're working on volume. They will give you this formula, if I can remember what it is. It's 1/3 pi r squared h. Okay. So what did they give us? dv, dr, or dh? dv over dt is 8, and it's filling, so it's positive. Find the rate of change in the depth. What is depth? Is it r or h? This is h. Who do we solve for? What we have or what we need? What we need or what we don't need? We're looking for the rate of change in depth. What do we solve for? R. We solve for what we don't need. So R is going to equal 6 over 10H, which is, how about 3/5 H? So now we're going to come up here and we've got volume equals pi over 3. I'm substituting now, but it still has an H in it, which means that it is not, what am I going to say? It is, it's changing, you know what I mean? It's not a constant because of the H. So this is going to be 9. I'm going to have 9 pi over 3 times 25 H cubed. Now I'm going to choose to stay small. 3 divides 9 how many times? So my volume is going to be 3 pi over 25 H squared. So now it's just going to be what? Thank you. What are we going to do? dV over dt is equal to 9 pi 25 H squared d. Why couldn't we substitute something for H before this? Because it's changing. We already said that we know our dV to be 8. What is H? The water is what? 8 feet deep. So this is going to be 9 pi over 25 times 64 dH over dt. Correct?
Will they give us that equation?
Yes.
They'll give us.
They will not give you the proportion piece, but they will give you the, yes, cone formula. Any of the big formulas will give you. So now I'm going to do the reciprocal, which is 25 over 9 pi. Now look, this is, let's say, non-calculator, okay? I did not take my time to multiply 9 times 64, did I? Why? How many times does 8 go into 64? It goes in there 8 times. So I'm going to have 25 over 9 times 8 pi. Now, oh, we can do that, can't we? 25 over 72 pi. Now, you could have left it like this if it was free response.
Wait, that's right. Why isn't that height?
Because it's all about the water.
Oh.
The tank is not changing. It's about the water. Other questions? Well, if we go to miscellaneous, okay, as I put my little binder back together, if we go to miscellaneous, there are some related rates in there. So why don't you look and let's do one. Why did I have this open in the first place? Anybody know?
Wait, this right.
Yes.
They give like a shadow type problem.
Oh, they did give us a shadow type problem. That is a related rate. I used to not teach AP Calc the shadow. And then one year, it couldn't have been 2012. Maybe it was 2012. Okay.
There's number 7 is.
Maybe it was 14. No, maybe it's 13. Oh, yeah. MC 81. Page MC 81. They're right there. There's a shadow problem. Next year, I started teaching that. Page MC 81. All right. So right now, we're going to go to miscellaneous because we were talking about related rates. Am I in miscellaneous? I am in miscellaneous. And I know there was one. And there looked like there was a cylinder. Number 6 looks like it could be related rates. Number 7 is a cone. What do you want to do? 6? All right, a coffee pot has the shape of a cylinder with radius 5. All right, this is a coffee pot. Pot? Interesting coffee pot. All right, what do you know about this coffee pot? It's not changing. This coffee pot is not going to change. What's going to change in the coffee pot? The coffee is going to change. All right, so here is our sort of diagram. Here is our coffee pot. And they're giving us some dimensions on this coffee pot, correct? Maybe. They said that the coffee pot's radius is 5. Let H be the depth of the coffee. So now we've got coffee somewhere in here. So this right here is h. There's our first variable. Measured in inches, so we'll make a notation that we're in inches. H is a function of time, so we know time is in seconds. The volume of the coffee pot is changing at a rate, dV over dt is equal to negative 5 pi square root of h. What does that mean that's happening? The coffee is decreasing. Then they told you that the volume formula is pi r squared h. So if we look, it says show that dH over dt is equal to the square root of h over 5 with a negative. So basically, this, if you see dH over dt equals, what should you do? What should you do? Derivative. dV over dt is equal to, oh my, what is this? Product rule. So we're going to say pi times, let's talk about the radius of my coffee. Is it changing? In fact, what is it always? So can I put 25 in here now? Why? Because it's not changing. So I need to rewrite this. Let me rewrite this. R squared becomes what? 25. And what's the derivative of h? dH over dt. Well, didn't they give us something here? So where do you think you're going to put that? On the dV over dt side, correct? So now how in the world are you going to solve for dH over dt? Divide by pi and 25. So we're going to divide by pi and 25. So the pi's are gone. 5 divides 25 5 times, so we have negative square root of h over 5. Oh my, did I do it? You get 1 point. Did I show it? So I'm thinking that we got 1 point for substituting this in for dV over dt. You get 1 point for this derivative, and you're going to get 1 point for showing the result. That was 3 points. Was that hard? Okay. Given that h is 17, the height is 17 at t equals 0. That sounds like an initial condition to me. H equals 17. Solve, oh my gosh, what does it say? I could have put this in the diffie-q part, couldn't I? dH over dt is equal to negative square root of h over 5. What's wrong with this picture? First of all, I'm making this dH over dt is equal to negative 1/5 square root of h, because that's going to be a whole lot easier. What do I have to do? Separate variables. So this becomes negative 1/5 dt, and this becomes 1 over the square root of h dh. All right, then what are we going to do? So we're going to integrate the left, we're going to integrate the right. Remember, that's h to the negative 1/2. So we add 1, we get 1/2. We multiply by the reciprocal, we get 2. And this is going to be negative 1/5 t plus what? C. What did they give us? 0.17. So at time equals 0, we're going to have 2 square root of 17. Wow, that's an ugly C if I've ever seen it. So we've got 2 square roots of h is equal to negative 1/5 t plus 2 square roots of 17. What did they say? It says solve for h. All right, I'm not done. Right now, what do I do? I'm going to multiply by 1/2, which means I'm going to I can do that, and then what will I do? And so I think what I'm going to do, I'm going to go ahead and distribute. Negative 1/10 t plus square root of 17 quantity squared. So you get 1 point for separation of the variables. These antiderivatives were simple, therefore the two of them together was 1. Constant of integration, and that was just C was 1. Using the initial condition, that means not finding C, but substituting 0 and 17 gave you another point. Solving for H gave you the last point. That was 5. So now, at what time is the tea or the coffee pot empty? So basically, what am I looking for? When height equals what? Do I have my height function? I want to know when my height equals what? 0. Well, what do I have to do? What do we have to do first? Square root 0. Okay. Then what? Add 1/10 t, and then what? At whatever 10 times square root of 17 was. This was a non-calculator. And you get 1 point for that answer. Yes. Okay, so we're going to do the shadow one. And it is MC page 81, shadow. I was so upset when I saw that year. I felt so bad because I didn't teach it. All right, a person. First of all, let's get our pictures. We got a street lamp. We got the ground. The street lamp has a light. We've got a person. All right. And this street line, I'll do it. Let me do a dotted line. The light hits his head and casts a what?
Shadow.
Look how long that shadow is. Hmm?
His head's bigger than the lamp.
All right. All right. Bye. Good luck tomorrow. Make sure you have new batteries in your calculators. Make sure that your calculators are in your car. Do not take them out of the car. Or if you're going to change cars tomorrow, make sure they're in your purse if you're your girl or whatever you take.
Car? I don't have it.
So that you don't leave them at home.
I think
Oh, no, didn't mean that.
Yeah, it was like.
No.
Why would I put your batteries in my calculator?
And then leave it in the car. That'd be pretty stupid. All right. It says the street lamp is 15 feet. And it says our guy is, I don't know, 6 feet. Okay. Now, that's because he's like this. Okay. So it says, what is the rate at which the person's shadow is lengthening? Do you agree this is the shadow? Because they gave us the man's rate, if you recall, this is always x. This is y because we want the rate of change of the shadow. If it had been the tip of the shadow, what would y have been? The whole thing would have been y. Now, what is the whole thing the way we've drawn it? X plus y. These are, what do we call, similar triangles. So we're going to say height 15 is to height 6, as large triangle side, which is x plus y, is to small triangle side, which is y. And if you recall, we went ahead and said 15y is equal to 6x plus 6y. Do you remember that? And then we subtract the 6y and we get 9y is equal to 6x. Do you want to do quotient rule? Or do you want to do a simple derivative? So now we're going to say 9 dy over dt is equal to dx over dt. Then we've got to see what we're given. It says the person is walking along at a rate of 4 feet per second, away from the lamppost. So that means that dx is getting bigger or smaller? Bigger. So that means this should be 4. Thanks for coming back. Nice. Thank you, Rain. At 5, we might get soaked. All right. So dy over dt is equal to 24 over 9. And then you have to reduce that to probably 8/3. Or actually,
Wait, why did
decimal.
you put 4 in for that one?
Because it's the rate the man is walking, not the shadow. Okay? Do you see how the x is next to the man? Actually, I will wait until this video stops and put it online because it won't do you any good tomorrow morning. Yeah, I'll make sure that that happens. All right, next.
I have a question about the test.
Yes.
I want to know what goes on. Like, what should I expect?
I don't know, but I've never taken an AP exam. You're going to go in. They're going to give you, you're going to get your stuff back that you bubbled. You'll get an answer sheet.
Oh, yeah.
You'll be given,
AP test, but I'm asking, like, what are the sections for the math?
the first thing you're going to do is 28 non-calculator multiple choice. 50 minutes.
15 minutes?
50.
Oh, okay.
Okay.
Do all of them.
Then you're going to do the calculator multiple choice in 50 minutes, which is about 17 to 19-ish. Because it takes you, yeah. It takes you time to enter into the calculator. All right. Then you're going to start the free response. You'll do your first 2 calculator ones, and you have half an hour for 2 free response calculator. Then your calculator goes away. And then you have an hour for the last 4. It's basically 15 minutes a problem. You can go back to the first 2 during that last hour. You can't touch the calculator.
I don't think they're gonna let us because the free response has always been separate from the multiple choice, and we have to seal the multiple.
No. There's, you can go back to the first part of that first.
No, not multiple choice. But when I'm grading, if I'm grading question 2, I pick up a packet, and it's all 6, and I have to turn to question 2. It's amazing. And so I get a packet of 25, a folder of 25. I grade question 2 on 25. I give it to this lady. She boxes up all the folders when they're done. That box gets sent somewhere else in that convention center to another table that will grade question 5. When that question is graded, it will be taken to yet another table of different people that will be grading number 3. So 6 different people will be grading your free response. 1 person per question. No, because you get to be an expert on question 2. At which point, because the details is ridiculous. At which point, you're slow in the beginning because you come upon things that they didn't anticipate, but eventually you get pretty quick.
Are you sad for people that don't try on your question?
I'm sad for the person, but that means it's a fast grade and I can go to the next one. So sometimes you'll open it up and there's nothing written. That's a dash. Next one.
Wait, do we get ours back? We don't get it
No,
back.
no. Who did I loan calculators to? Did they take them with them?
No one gave it back.
Oh, did she put it back? Okay. All right. So just that was it. Just the logistics of how the grading is crazy. And I never have seen any of my tests because I look at our number, we're 100, 254. And I'm thinking, boy, they were smart. I don't know how they did that. So then I asked the guy, I said, how do you make sure we don't grade our own papers? He says, well, if there's 2.4 million questions, what's the probability that you're going to get one of your students' questions? Last year, there were probably 900 AP Calc graders.
900.
I graded 3,500 questions.
I'm gonna put high smiley face on mine.
Oh, we can't write on them. We can't write anything on the booklets. So when I'm going through, I have this tablet next to me. And so, you know, the first question might be 3 points, and they'll tell you how to get the first point, how to get the second point, how to get the third point. So I'll be doing 1-0-1, which means I got the first point, not the middle point and the last point. And so then I'll total them up, and then I'll bubble it on a bubble sheet. Because if you want to contest it, then they will pull your packet. And if I've written on it, I might have changed something you did. Yes, yes, yes. And in fact, I have a pencil. When I go up to talk to the lady, I can't point with the eraser because I might erase something. Yeah. It's crazy. Okay. It's Kansas City, Missouri. It's grueling, all right, but every 2 hours we have a break. You can have bread. They feed you, then they feed you at the break after 2 hours, and you have lunch, then you do 2 hours, and you have another feeding, and then, yeah. You make math friends, so like the first year, my roommate, we just happened to be put together, the second year, and so now we request each other. So she's been grading longer than I have, so she's from the Ukraine, so she has a friend from somewhere in Moscow, I think. Anyway, Oksana usually grades every year, and then last year I was introduced to another guy, I don't remember his name, but he was from Moscow, so I'm interacting with all these Russian people. All my friends are Russian. So, you're called an acorn your first year, and then I have yet to be given an acorn, so I'm hoping this year I might get an acorn. That's a newbie.
What's an acorn?
An acorn is a person that's first year grading. So they put you next to someone who's graded, so, they will ask you a lot of questions. Yeah. So we got 17 more minutes. What do you want to do? Yes. Okay, so now if we're going to do tip of shadow, this is no longer y, and that's no longer x plus y. This becomes y, and then this becomes y minus x. I would like to do a table, because I didn't do very many tables with my people. That means that instead of the highlighted area, how quickly is this little tip of the shadow moving? It moves at a different rate than the shadow's changing. Yeah, and we did both. So I don't remember what we did yesterday. Anybody remember what we did yesterday? Pot of tea cools, temperature of water in a tub. There's a coffee cup. We did number 9. I think we did number 8. Pardon? Explain limits? What about limits? So basically you substitute. If you get 0 over 0, do the derivative of the top, derivative of the bottom until...
Okay, yeah, but is that for... There's like different types, right?
Oh, you're talking definition of derivative. Are you talking about, like...
Yeah.
Look at MC, hold on. Look at MC page 35. MC page 35. Is that what you're thinking?
Yeah, if I get one of those.
Oh, I guarantee you will get one of those.
So like,
That is on the 2000, that's on the practice exam. This is the 2012 multiple choice. There's one in there. I downloaded another multiple choice test, which was either 13, 14, or 15. There's one on the, you are guaranteed. Okay. Do you remember the 4 forms? So this is derivative. This is definition of derivative. Minus f of x all over h as h goes to 0. Okay? Now, that's the definition of derivative. What you most likely will see is c plus h minus f of c all over h as h approaches 0. This is the derivative. This is the derivative at x equals c. However, we also did the limit of f of x minus f of x minus h all over h as h approaches 0. That would look like limit of f of c minus f of c plus, that should be minus h. Let's see, this is going to be c minus h all over h as h approaches 0. That's the derivative again at x equals c. All right, so now let's go to limit of f of x plus h minus f of x minus h all over h as h approaches 0. That could be the limit of f of c plus h minus f of c minus h all over h as h approaches 0. And then our last one was limit of f of x minus f of c all over x minus c. Look how different that is as x approaches c. There's no h's. So what you're going to see is what's usually on the right. You with me? Over here. What this is saying is it's saying take the derivative. So we're going to look at number 14. It says the limit of e to the 2 plus h minus e squared all over h as h approaches 0. Yes? Oh, I'm sorry. This is 2h in the denominator. Thank you. Okay. So this is not this because it doesn't have an x. This is a plus h, which means it's the top one. So if you recall, what we used to do is we said this becomes x. So the function is e to the x. Now, they're saying take the derivative at x equal what number? What did replaced x? 2. 2. So what we're going to do is we're going to say, all right, the derivative, how do you do the derivative of an e? ln of the e to the x times 1. I'm dragging it out. F prime of 2 now is going to be e squared. So now let's go to 2012. Let's do another one. MC 71. Because this is the definition of derivative. All of these up here say take the derivative. That's what they're saying. They're saying take the derivative. What if I look at this and try to do a limit? It's like I have no clue how to do that. But if you remember that's derivative, find the function, then it's easy to do.
Wait, Miss Mark, I thought you can just like cancel. But
Cancel what?
I don't know.
If you put 0 in, you have e squared minus e squared over 0. This is definition of derivative, yes. The fact that this is 2 right there. And notice, if we come up here, do you see that the 2 is here? And what did it replace? X. All right, are you on MC 71? There's another one. I'm telling you, it's going to be on the exam.
I have another question.
MC 71, number 18.
Could you also when the derivative, no, not the derivative, but when the limits are going to infinity, is that when you do the factor, not the factoring?
1 over x highest, yeah. Do you want that or you know what you're doing? Okay, some of those are in the beginning. This is as h approaches 0. Okay, so it's the same form, is it not? What is your function? You all did a worksheet of 20 problems on this. ln x. Now this is saying take the derivative where? They're asking you for f prime of 4. How do you do the derivative of a log? 1 over x. So what's the derivative at 4? 1 over 4. All right, hold on. We're going to do one more because I'll find it. It's in here. 2008 didn't have one. This is my new, it was 20 on whatever year this was. It's not labeled. All right. So now let's do, this is the limit of ln of x plus 3 minus ln 5 all over x minus 2 as x approaches 2. Now that's a different form. Okay, let's go back up and look at this form. I want to make sure that you're aware when it is the x approaches c and the x minus c in the denominator, this first thing is what? It is the function. So if we look at this, what is this function? The function is not just ln x, it's what? It's ln of x plus 3, that whole thing. So now what is the derivative? 1 over x plus 3 times 1. And what are we approaching? I mean, what are we taking the derivative at? 2. So that's going to be 1 over 2 plus 3, which is 1/5. I'm telling you, this is an exam question. No question about it.
So all we have to do is we just have to identify the function.
Identify the function, do the derivative and substitute.
Do we really like have to actually try and like memorize all of them, or can we just like look at the general form? Because isn't it whatever is in like the correct, like whatever's plus that, like the h or whatever, you just
Okay. So bottom line, if you have an x minus c, it's the function is right there. Otherwise, it's going to be wherever the 2 plus h is or the 4 minus h is, you take that and that should be your function. Okay. So someone asked me a question before I finished this. What else did you want to do? Somebody asked me something. $92? 55.92. F is a function. Oh, this is a calculator one. So I think I'm going to go to a new page. So we have f of x equals, nope, that's f prime of x equals sine of x cubed. All right, that's already the derivative. Oh, notice it's 0 to 2, so that's what I'm going to do to my calculator. Maximum for f. They want to know at what value of x. How do you look at this when you have a first derivative? So we're going to clear this. We're going to put sine of x raised to the third. Okay. And then I'm going to come here, and I'm going to go 0 to 2 because I don't want to look beyond what I'm supposed to see. All right. This is a derivative graph. I want a maximum. Is it a maximum? Okay, I need a maximum. How do you look at a derivative graph to find a maximum? Okay, so we're going to look here, and we're going to look here. We went from positive to negative, negative to positive. Which one's the max? The positive to negative. So that means you're going to have to do second trace. You're going to choose 0. And am I to the left? All right. Right bound, I'm going to choose, I better not. I have to move it. I find this so tedious. All right. So there's that one. So it is 1.464. Do they have that? Yep. Parts. Yeah.
So the max would be it's where it causes the x-axis.
So if this is a derivative, we see that we've got two critical numbers. And this, when the derivative is above, that means the function's increasing. When the derivative is below, we know the function's decreasing. The derivatives, does that ring a bell?
Yes.
Okay.
Zero?
0, because a 0 is when the y equals 0. X-intercepts are zeros on the calc menu. Okay?
Oh, you did x-intercept?
The x-intercept is 0, not intersect. Okay, let's go to the calc menu. Intersect is a point of intersection. 0 are your x-intercepts. So whenever you want to...
The number that you had.
Did you type in your function correctly? You sure?
Oh, it is the same one.
Okay.
Because it had guess.
Oh, you have to go past guess.
Yeah.
All right.
Like, why?
Any other questions? Any other questions? You need to get a good night's sleep. I've been told that if you eat fish, that's brain food, that whenever you have a big test, you should always have a fish dinner. Have you heard that? I heard that.